Laws of indices. Okay, we're going to have a look at some of the laws affecting powers. Start over there. If I've got a cubed times a squared, notice the letter A, they're both A's there. So all I do in this instance, provided both letters are the same, is I write the letter out, A, and I add the 3 and the 2 together in this case. So A will be to the 5. 3 plus 2 equals 5. Another one, we've got C to the minus 7 multiplied by C to the 4. So both letters are the same. First check, C minus 7 plus 4 then gives me minus 3. Because remember, when we're multiplying two powers where they've got the same letter, we add the number at the top, or the index. Okay, we've got E to the 4 times F to the 7. This time letters are different, so you can't mix them. So the result simply becomes E4, or E to the 4, F to the 7. The only thing we can eliminate is the time sign between them, because in algebra, remember, if the letters are smudged together, it's the same thing as a time sign. So that's different letters. If we go on to dividing indices now, we've got x to the 9 divided by x squared, or x to the 2. Sometimes you might see it written like that. Those two are exactly the same thing. That's a divide sign in algebra. What we do when we're dividing, instead of adding, we now take away. Alright, so we've got 9, take away 2 gives us x to the 7. So dividing we take away. We'll do another one for practice. We've got y to the minus 2 divided by y to the 4. So the letters are the same, so we can press on with that. We've got y, so minus 2 take away 4 is minus 6. That's y to the minus 6. So those are the first board there. A few examples to get going. If we've got a number in front of the indices, what we do is we treat it as normal. So big number before, we just do it as normal. We don't add, so we just do times 5 times 4 in this case. So the big number in the answer is going to be 20. Now we're going to deal with the indices. Look at the A's first of all, our first letter. We've got A to the 6 here, and we've got A to the 2 there. So all over, that's going to be A raised to the 8. Same thing we do for the B's. We've got a 3 there and a 7 there. 3 plus 7 is going to be B to the 10. Okay. Next bit. We've got 12 C d to the minus 4 times 3 d to the minus 3 e to the 8. So let's be careful here. Let's deal first things first. Those are the numbers at the beginning. 12 threes, 36. That's that bit out of the way. C squared, haven't got a C in the second term, so that just stays as C squared. We'll see the 2. The D's now, I've got a minus 4 and minus 3. Remember, we're times till we add them. So minus 4 plus minus 3 actually gives us D to the minus 7. And then finally, I haven't got an E here, but I've got one there. So I just write it as E to the 8. Okay, next thing, dividing. So we're going to have 6 x to 7 divided by 2 x to 5 y to 4. Same way, we've got our blue numbers here, the big numbers in the front. Just do a normal division there, that becomes 3. So we forgot about the big numbers in the front. We've got x to 7 divided by x to 5, that's going to be x squared. And then we've got y to the 4, but we're dividing by y to the 4, so we haven't got anything there. So as if we've got a 0, so that actually becomes y to the minus 4. Because 0 take away 4, because this y is in the, after the divide sign, it becomes negative. Another way you could write that, you could write it as 3 x, and I'll put all the black bits in there, so x squared over y to the 4. So the minus 4 you can actually write as a divided by plus 4. And we'll do a little bit more of that in a minute, so I'll show you that. Final rules down here come to when we've got an index raised to another index. What you do for that one is, this is where you multiply. So if I've got k to the 4th and the whole thing's raised up to the 3, that becomes k to the 12, because I've times the 4 and the 3 together on that one. Okay, and this one here, we've got 5k to the 4 raised to the 2. So I'll just deal with the k bit first. The 4 times 2 bit, the same as this 4 times 3 bit, that becomes 8. Now, 5 squared then becomes 25, so we do 5 times 5 on that one. So, you'd raise the blue, the big 5 in front, the 2, that becomes 5 squared, but the power you would multiply. So those are the differences there. So study that one carefully. Right, the last sort of strip of board is a couple of tricks they sometimes play on you. If you've got anything to the naught, 7 to the naught is 1. If I've got 375,678 to the naught, the answer is still 1. So absolutely anything raised to the power of naught is always going to be 1. If you see something raised to the half, a fraction for the index, it means exactly the same thing as square root. So raised to the half means exactly the same as square root. Remember, a square root is what is the number that is times by itself to give you 64. Well, 8 eighths make 64, so the square root of 64 is 8. Remembering 8 times 8 is 64. We'll just do that as a little memory jog there. Okay. Finally, if I've got a negative power, we came across this just slightly over here. It means 1 divided by the positive power. So to get rid of the negative power, you write 1 over, and it's the same thing, but with the positive power. See how the minus sign has disappeared there. Now, 1 over, now 2 to the 3 means 2 times 2 times 2, isn't it, which is 8. So the answer to that one will be 8. So there we are, there's an introduction to the laws of indices and a few special cases on the board here.